Hi, boys and girls. Okay, boys and girls, we are going to continue our lesson. Okay, before we continue our lesson, there is one bad news I want to share with you. It's because I did trying to send out the new worksheet to you guys, but I didn't realize that the school Wi-Fi is so poor. At the end, through WhatsApp, it doesn't successful to send out. Then at the end, I didn't send out because of the poor Wi-Fi. So it's okay. So today we continue our lesson 34, 35. If I'm not mistaken, right now you having 34 and for 35. But I wish actually if we can faster, I want to continue further lah. So later on we see how. Okay, boys and girls here. So we start right now. Okay, here. Okay. Stationary wave. Last week we learned about stationary wave. So at here, the sound wave can produce stationary wave in air column or pipe. So this is the 3 point. How we score if they're asking you how to producing the stationary wave. Okay, it travel and then we got incidence wave, then reflected wave. Okay, then after that they superpose. So at the end we form the stationary wave lah. Okay, last week we learned about both is closed. Is it both end is closed? Okay, so at here today we learn about one end closed, one end open. Okay, so another case is both end are open. So from this diagram, can you see this one? If the end part at here, it must be a nut. It must be a nut. If open area here, it must be an empty nut. So this one is the same. You see, both side at here, both end are open. So both end at here actually is empty nut. Okay, empty nut. So this one is summary. Later we'll learn. Okay, why for the one closed, one open, we will get fundamental frequency. Then next one we will get the third one. Why not the second one, teacher? Okay, last week we learned F1, F2, F3 continuous. Okay, but today for the one open, one end, you will find out that they will have the sequence, but only for the odd number of harmonic. Okay, so here you can see from the diagram, there will be always empty note at open, not at the close. Okay, so we goes to page number 2. Okay, we study only odd number harmonic can be acid. In this case, one end open, one end close. So before that, please remember our one complete path is like this. One complete path is like this. Or actually here, you look at, okay, we look at this case like this to this. Actually, what is your wavelength? How many of your wavelength? What do you think? Okay, so at here, this one, it will reflect like this, like this, like this, like this, like this. This is called one complete wave. Am I right? This is one complete wave. Half of it, this is called half wavelength. So this one is half wavelength. So you look at this, the actually how many wavelength? So you look at this part, the. Can you see? This part actually is my part at here. So how many complete wave? Actually is 1/4 wavelength. For the first case to fulfill this, okay, the pattern of the wave, okay, stationary wave, for the first case, fundamental case, we will find out that this shape, actually this length is represent 1/4 wavelength. 1/4 wavelength. So your wavelength actually at here, this one move to another side. Wavelength is actually 4L. Wavelength is all actually 4L. So your frequency, okay, V equals to F lambda. Frequency is V over lambda. So your wavelength is 4L for the first case. You always remember the first harmonic, or we say fundamental harmonic, they were having the longest wavelength. That's why you see the wavelength is 4L. Okay, so we will get this pattern FO equals to V over 4L. This is fundamental frequency. Okay, we look at the second pattern that it may be formed. We adjust the frequency and so on. Then we get here. Because we need to fulfill here must be anti-node, here must be node. So this is the pattern that we will get. Okay, so we look at here. This one is equals to how many wavelength? So if according to my diagram here, it should be like this, go here. Am I right? This, go here. So can you see that this one actually is how many wavelength? 3/4 wavelength. Am I right? 3/4 wavelength. Okay, is this. Okay, so I get the length is actually represent 0.75 wavelength. Okay, we substitute this inside the formula. At the end, we found out the sequence. Can you see? This one is FO. Okay, this one, after we get the second pattern, okay, the second pattern that we able to get, we found out that actually is third harmonic. Third harmonic. It won't be appears second harmonic. So at here, for this case, only odd number of harmonic will be appears. So at here, the next one, the harmonic actually is third harmonic due to the one close, one open end. Okay, so we look at the fifth harmonic at here. So this is considered one complete wavelength from here to here. This is one complete wavelength. Am I right? Then this one is just now we say the first case 1/4. So for this case, it's actually 5/4 wavelength. The third pattern that we can get is 5/4. At the end, we do substitution again. We prove that FO, 3FO, 5FO, then 7FO. For this case, it only have the odd harmonic. It only have odd harmonic. Okay, so we try here. Okay, a musical organ produce a note by blowing air into a set of pipes that are open at one end and closed at one end. Okay, so like this. Open at one end, close at one end. The speed of the sound is 300. Okay, this one we write V. I know that this is the speed V. What is the lowest frequency? Lowest frequency, that means that our fundamental frequency lowest frequency. If you lowest frequency this one you see lowest frequency. This one is 3 of FO. So this one getting higher. Okay, lowest frequency, that means that you having a longest wavelength. Longest wavelength. So this is the pattern they ask. Okay, lowest frequency. So this one is lowest frequency. So this one, the shape that we want actually is like this. So we draw it down. Okay. Okay. Here, a pipe of 10 meters. So from here to here is 10 meter. L equals to 10 meter. So how we find out the frequency? Okay, the frequency from here, frequency is actually V equals to F lambda lah, okay? So at here, your speed is 320. Your frequency is unknown. What is your wavelength? What is your wavelength? So you ask yourself, the 10 meter represent how many wavelength? So this one 10 meter actually is how many wavelength? Okay, so just now at here, you see this part. Here, antinode to node here. How many wavelength? 1/4. 1/4. So I know that this is 1/4 wavelength. So wavelength equals to how many? 40 meter. 40 meter. So you using this information, put it in, you will get the frequency should be 8 Hertz. Okay, for this example, did you get the idea? Use the length to find your wavelength. Then you just do substitution. This one, is it okay? Do you get the idea to do calculation for such kind of question? If okay, can you give some reaction? Okay, Fawa, okay, Vashini, okay. Then we go to page number 3. Page number 3, okay? We go to page number 3. Okay, this one, they are very nice. They draw for you. Can you try to find frequency by yourself? This one, I left it for you. This is the second pattern that we can get. So what is the frequency? Ask yourself, 60 cm represent how many wavelength? My boys and girls, you try. And then tell me what is your answer. Wesley, very good. Machining, very good. Oh, good job. Okay, boys and girls, so this one is equals to 3/4 wavelength. Because one complete wavelength is like this. Okay, one complete wavelength is like this. Okay, this is one complete wavelength. So now we are at here. We are at here to here. So this one is 3/4 wavelength. Okay, so I just turn only like this. Turn to vertical only. Okay, this is one complete wavelength. So now it's 3/4. So at here, you just calculate the 60 is equal to 3/4 wavelength. So wavelength should be 60 times 4 divided by 3. So the 80, is it? So at here, this one is cm. Oh, okay, cm. So boys and girls, please make sure you convert. V equals to F lambda. So 340 equals to frequency 0.8 meter. Remember this one convert to meter. So frequency you should get 430 hertz. Answer should be A. Let me have a look, Manjo. Yes, correct. Okay, dear, can we go to question number 3? Let's go. Should be fine, right? Similar with just now the example one. Okay, now it's just second pattern of this harmonic. Okay, here. Again, one close, one end close, one end opener. Have two NP notes. Oh, have two NT notes. So that means that we have to draw it out. Two NT note. We look at here. Which case they ask? This is only one NT note. So this is 1, 2. This is 2 NT note. So that means that what they're asking right now is the second case. Okay, so we have to draw. Same like this one now, okay? Question number 2. So you have to draw like this. It will roughly like this, okay? Although a bit ugly. Okay. Antenna at open. Okay, the length, total length is 0.6 meter. The speed of sound is V. Okay, boys and girls, can you count? It's same like just now, similar. Do I need to continue? 0.6, it's the same thing. It's the same thing, what? Question 2 and 3 is the same thing, Just question 2, they provide the diagram. Question 3, they didn't provide the diagram. It's the same thing. Okay, no need to do lah. Answer is A. I accidentally found out it's the same thing. Prasan correct. Wesley correct. Okay, so number 3, no need to do. Number 4, okay, boys and girls. A straight tube is closed at one end and has a loudspeaker position at the open end. The frequency is very low and increase slowly. A series of loudness maxima are heard. The stationary wave will give the first maxima at a note at the close end. At close end and anti-note at the open end. Okay, frequency is F1 when the first maxima is heard. What is the frequency when fourth maxima is heard? Okay, dear, because here they're mentioning one open, one close. Am I right? One open, one close. So it's the case that we want. Okay, so at here we understand for our question about this. Our F only have what? Our F is only have Fn is only have n equals to 1, 3, 5, 7 and odd number continue. Am I right? For this case, it can be appears only 1, 3, 5 frequency. Harmonic, okay? So at here, you look at this. What is your answer? What is the maximum, what is the frequency of the loudspeaker when the fourth maxima is heard? A, B, C, D. What do you think? Fawal, no. Fawal, no. How about others? What do you think? Manjo, correct. Washini correct. No ha, dear. Prasan correct. So, dear, first, how you identify? One open, one close. So, it's our case, this case, okay? So, the frequency, this one FO, or they say F1, doesn't matter, okay? So, at here, because F1, so F1, the next one is actually what frequency you can get. You can get 3FO. Next one, 5FO. Continue, 7FO. Only odd number, only odd number for our one close, one open end. Okay, so at here, they say that the frequency is F1 when the first maxima is heard. So in this case, it can hurt the maxima, first maxima. This one FO. In their question at here, they're using F1. They're using F1. So we understand the next one should be N times F1, but the N that we can have only odd number. So 1, 3, 5, 7. For maxima, so that means 1, 2, 3, 4. 7 F1, 7 F1. Okay, so I come back to here. You see, this one is the first maxima I can hurt. This one is the second maxima I can hurt. I continue adjust. Then this one is the third one. And the fourth one. Fourth one, how I know? 7FO. FO, 3FO, 5FO, and 7FO. So at here, 7FO is the correct answer. But why not writing FO? Because here they're giving you F1. They say first maxima sound can be heard. This one is F1. They label F1. Just now our notes is labeled FO, but doesn't matter. It's just a symbol. Okay, for question number 4, is it okay? Fawao, is it okay, Fawao? Okay, so we goes to your next question, dear. Okay, only Fawao okay? The rest of you okay? Can we proceed? Yes, okay, thank you. Okay, this question I saw it before. I saw few times before. Okay, here is a long tube. The other end is open. Another end is your mouthpiece at here. Close it. So here open. One end open, one end close. Okay. Not at mouthpiece. So this one is closed. Then empty not at the another end. Lowest frequency. Okay, this is lowest frequency. FO. Again, this is open. This is closed. So our frequency, continued frequency will be NFO. Again, it will be N only 1, 3, 5, 7 and continue. Okay, boys and girls. A, B, C, D. Which one frequency is the possible frequency that you can get? Oh, Prasan very fast. Yes. How about others? Let me have a look. Jore, correct. Any others? The frequency at 92. The next frequency you can detect should be Fawao, correct. So boys and girls, the next frequency that you should get is 3 times 92. 5 times 92. 7 times 92. So your answer should be C. You must identify what is the case right now. One end open, one end closed. So we need to follow this. The frequency should be end of fundamental frequency, but here the end only is odd number. Okay, is it okay? If okay, we goes to question number 6. Is it okay? Okay, Fafa okay. How about others? Machine okay. Who else? Who else? I haven't take attendance. Jahan okay. Oh, good job, Jahan. Okay, dear. Next, come here. A stationary sound wave is set up. Okay. A loudspeaker and the wall. The microphone is connected to a CRO and it moves along the line between the loudspeaker and the wall. The amplitude CRO is raised to a maximum at position X. Okay. Then after that, fall to a minimum and then rise again. Okay, here, maximum. So at here, this is anti-node. Fall again to minimum, so it experience node. Then rise again. Again, we have anti-node. Okay, rise again to a maximum to position Y. The distance between X and Y is 33. The speed of sound is 330. So this is V. Okay, a loudspeaker and a wall. If like this, I draw. This is wall. Let's say this is the wall. Okay, this is the wall. So this is the loudspeaker. Okay, I understand that this one, the wall, wall at here. The wall must be a node, okay? So at here, they say that antinode. So here is X, okay? X is an antinode. So something like this, antinode, okay? Then it will experience a node. This is the node, no? Then it will have an antinode at here, point Y. So that means that somewhere here is the antinode. Okay, here is the antinode. Oops. Oops. Wait. Go back. Okay, here, like this. It will be roughly like this. Okay. This one, you see, this one, Y, Y at here is antinode. From here, antinode. This one, antinode. From here to here, X to Y. Actually, is your 33 cm. Okay, I cannot draw my anti-node at the wall here. So I forced to have another one more distance so that I can create a node at the wall here. Wall is a closed end. So it must be an anti-node. That means that what they mentioned is until here only. They didn't continue mentioning until the wall. Okay, so anti-node, node, anti-node. Because the wall, so I know one more node. Okay, so boys and girls, can you try? Can you try? So from here, what you have? Let me have a look. What information you have? 33 cm. So from there, you can find your wavelength. Am I right? From your wavelength. Okay, first step, I give you some hints. First step, find your wavelength. Second step, V equals to F lambda. Find your frequency. From your frequency, because this is a CRO. CRO, we know the time. One complete wave is the period. So from the frequency, we find the period. Then from there, can you determine which one is your correct answer? Okay, so boys and girls, these three steps. Let you digest and then you do it. First, from the 33, find out the wavelength. Those who have no idea, I roughly continue give you some hints. Those got idea, then you continue. Those who have no idea, I continue give you some hints. You try. Wow, Wesley, very fast. Good job. So fast. Want to take attendance. If you guys get the answer, you let me know. I take attendance for today's lesson. Jory, yes. Bashini, yes. 开谦 I didn't saw 开谦 Prasan yes, Yueting yes, Fawao yes, Fatima today, holiday, because of Para. Tony, I didn't saw Tony. Manjo yes, Boyang no, Wesley yes. Okay. Okay, let me have a look. Fawao correct, good job. Vashini correct. Manjo no. Okay, boys and girls here. You see, I already draw out. This is one complete wave. If you feel very weird, actually it's same like what we learned in year 10. Like this is one complete wave. Then it reflected only. Okay, so this is one complete wave. This is one complete wave. Okay, now we are from X to Y. Actually, it's this part, X to Y. Half wavelength. So half wavelength is 33 cm. So your wavelength, it should be 66 cm. Or I say 0.66 m. So this is my first step. Okay, then after that, V equals to F lambda. My speed is 330. My frequency unknown, my wavelength is 0.66. So my frequency should be 500 hertz. But from the CRO, what we can know is the period, it's not frequency. So we need to continue find the period. Period is 1 over frequency, which is 1 over 500. So at here, I get 2 times 10 power of negative 3 seconds. Then, one complete wave means what? Okay, here, this is one complete wave. You see 1 cm. Every 1 cm is 0.5 millisecond. So here, how many? 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay. This one is wrong here. Wait, let me erase. Okay, one complete wave should be like this. Here goes to here. So 8 box. 8 times 0.5. So it's something like what? 8 times 5. 4 lah. 4. Right? 4. So at here, this is A is not our answer. Okay? It's not our answer. 4 is not our answer. Okay, so this one is 2 millisecond to have one complete wave, but this one is using 4 millisecond to have one complete wave. So we look at B. B. One complete wave is this. This is one complete wave. How many box? 4 box. 4 cm times 0.5. So at here, this is 2 millisecond. Answer should be B. Tally. Okay, so C and D, if you do, you found that it's not 2 millisecond. Okay, until here, is there any question for question number 6? Any question? If no question, give me a response. Then we go to next question. Okay, Fawa, okay, Vashini, okay. Manjo, okay. Can repeat. Okay, my dear, can, no problem. We can repeat for a short while. For those maybe you don't want to listen for this explanation, you may try question number 7. But for those still not clear, now I explain one more time. Okay, one complete wave, dear. One complete wave is like this. In year 10, we learned this is one complete wave. Okay, so when the wave coming and then it hit something, so it will be reflected. Okay, so we form stationary wave in our A level. So this one is considered one complete wave, right? So in this question, they say that the loudspeaker, okay, is a maximum at X. Okay, the CRO showing that maximum is at X position. X maximum, that means this is anti-node. So my X is starting from anti-node X at here. Then goes to minimum is not. This is not. Anti-node, not, then anti-node again. Then rise to the maximum at position Y. So this is position Y. Okay. Then after that, what is the wavelength? How many wavelength for this? Anti-node to anti-node. You can think like, anti-node to anti-node. You see just now, from starting to ending is one wavelength. Right now at here is 1 over wavelength. Okay, until here, Wesley, do you get this idea? This part, is it okay for you? From the X to Y, yeah, okay, huh? Then after that, I want to know the frequency. From here, I can know the frequency. I got the wavelength. I got the frequency. Okay, wavelength 1 over 2 wavelength. I know that they tell me x to y distance is 33. So I know that this is 33 cm. So your wavelength should be 66 cm. We want to apply with V equals to F lambda. Please make sure you are using SI unit. Because my speed is meter per second. So here I cannot using cm. Convert to meter. At the end, I get 500 hertz. So until this step, oh wait, you get it right now? Okay, good job. So I no need to continue, Wesley? Is it? I can skip? Okay, yes, the idea. Next. Like boys and girls, can you try? Draw a letter A at position anti-knot. Where is your anti-knot? The open area here lah, anti-knot level. Speed of sound V. Ask you to find frequency. Easy. Easy. It just wants you to using the formula V equals to F lambda. Like boys and girls, type your answer in the chat box. 3 marks, please. Formula, substitution, and final answer. Thank you. Now, let me check. Bashini, good job. Prasan, wait. Okay, I wait for you. How about others? Ask yourself how many complete wave. Jore, correct. How about others? Manjo? Prasan, correct. So what is the mistake just now? Fawa, correct. Fawa, I want you make it two significant figure. Manjo, correct. Good job. Wesley? Okay, Wesley, you ask me. I ask you, not you ask me. Wesley, this one, how many complete wave? How many complete wave? First question, how many complete wave? Okay, the complete wave is like this. Then it will be reflected, yes. Okay, so for this part, how many complete wave? How many wavelength? Okay, wait. Fawa, correct. So boys and girls, Wesley, you try one more time. You see, from here to here is one complete wavelength. So for this part to here, actually is 1 over 4 wavelength. Okay, from here to here is half wavelength. Right? Okay. Then, so V equals to F lambda 340 equals to your frequency is unknown. Wavelength, what is my wavelength? 1 over 4 wavelength is 4.5 times 10 power of negative 2. Wavelength should be 0.18 meter. So substitute in, your frequency should be 1900 hertz. Okay, Wesley, you get 19. But where is the 00? Is it you didn't change something? Something you didn't change? Okay, you try, Okay, here. So boys and girls, Wesley, is it okay for this? Yeah, okay. There, the piston is moved towards to your left. So that means that I move somewhere here. Move to here. Okay, move to here. Maybe later on I draw a new one. Okay, move to the left. So here, like this, like this. So we move to the left is, okay, something like this. Further away. Okay? Then after that, this one becomes longer. The length become longer. Am I right? Okay, then they say that the frequency emitted is changed. Oh, they change frequency so that the stationary wave is formed with the same number of anti-nodes. So first, ask yourself, how many anti-nodes in this figure 4.1? We only have one, right? So supposedly, when you move and make it longer, maybe we will get able something like this, then get like this, and then get like this, and get like this. We get the second pattern. Supposedly, if we didn't change the frequency, I will get this. But at the end, they say that they adjust the frequency so that they're having same antenna. I only have one. So right now, I goes to my new position here. I still getting only one. That means that this one like this. You get what I mean? They adjust until they're getting back this pattern. Only one antenna. Same number of antenna. How many antenna? Only one. One antenna. Here, one antenna. Okay, so if like this, that means that this one, your length become longer. The length at here become longer. Okay, what happened to your frequency? The length, how you relate to frequency. Just now we keep on doing the work, right? From the length, you can find what? From this one, you can find what? Using the formula, you can find the frequency. So ask yourself, when your length become longer, what happened to your wavelength? What's going on with your wavelength, and then what's going on to your frequency? Like boys and girls, try. Yes, very, very good. Wait. Wow, yes, second answer is correct. Yes, Wesley, correct. Jore, correct. So, dear, this is still 1 over 4 wavelength, right? If your length become increases, that means that your wavelength will be longer, right? If here 4.5, let's say we move to 9. Here is 4.5. If let's say I move to 9, so here I become 9 times 4. Of course, this value will become higher value. The wavelength will become higher. Okay, then at here, wavelength become higher, and then why frequency becomes smaller is because V equals to F lambda. The speed is the same all the time. With here 340 is a constant value, 340 meter per second, ms negative 1. So when your wavelength become longer, your frequency should be smaller. So I will answer at here, state and explain the change. So what happened? The frequency is become lower. Frequency lower. Why? Because wavelength becomes longer. You don't using symbol, I can using symbol, you cannot. Okay? Until here, any question? If okay, can you give me response? Then we go to page number 6. Mashini okay already? Wesley okay? Manjo okay? Fawa okay? Jahan able to follow at Jahan? Fawa okay? Jahan okay? Okay, like boys and girls, we go to page number 6. You think okay or not? You think if not okay, let me know. Or you shy, you maybe WhatsApp me. Okay, here, like boys and girls. Now, third case, both ends closed, both ends open, okay? Open must be antenna. Must be antenna. Actually, it's the same thing, lah, dear, okay? So at here, for example, this is one complete wave. So like this. This is one complete wave, One complete wave. Okay, so from antenna to another antenna, that means that from here to here, this is half wavelength. So if we do substitution for the wavelength, then we get the frequency is this. Same thing, same thing. It's just how we identify how many wavelength in the length. Okay, then for the second one, how many wavelength, complete wavelength? From here to here is half. Then continue from here to here is another half. So for these, actually it's one complete wavelength. It's one complete wavelength. Okay, it's one complete wavelength. So for this one, from here to here is half. Then continue go up. This is one complete. Okay, you can think like crest to crest. See, crest to crest. One complete wave. So this one 12 to 12 is one complete wave. So at the end, we do substitution and we compare to your fundamental frequency. I found out that the second pattern that we can get, the frequency is 2FO. So from here, we can get FO, 2FO, 3FO. Only just now the spatial case for the one end open, one end closed. It only have odd harmonic can be appears. For both end open and both end closed, they are both can be using NFO and then N is starting from 1, 2, 3, 4. Okay. So we go to your page number 7. Now let's go. Okay, here is the summary. You see, both end closed, both end open. They are both can be 1, 2, 3 and continue. Only the second case, one end closed, one end open. This case only 1, 3, 5, 7 and continue. Only odd number. This is summary. The method how we solve actually is the same. Okay, so at here, look at here. A tube of length L is open both ends. So open up both ends, that means that here must be antinode, here must be antinode lah. Okay, a stationary wave is set up in this tube when a tuning fork vibrating with frequency Fx. Okay, then this is the lowest frequency. Another tube of length 2L. Okay, this is second case. Antinode here is closed, so here must be a node. Okay, so they say that a stationary wave is set up in this tube when a tuning force is Fy. Okay, this is the lowest frequency. So this is also fundamental frequency for the one end closed, one end open. So at here, if like this, then your pattern should be like this. Your pattern should be like this because this is the lowest frequency. Something like this, then something like this. So this one, if antinode is here, so it will be like this, then go here. So like this, go here. Okay, for my diagram, is it okay? Okay, so how we are going to find the relationship between Fx and Fx and Fy? Okay, they want to find what is the equation is correct. So what can we do is here is from here to here. Okay, it's how many wavelength? It's half wavelength, am I right? Again, y half wavelength here, y half wavelength. From here to here is half wavelength. Okay, so half wavelength is equals to your length. So wavelength is equals to 2L. Yes. So V equals to F lambda. Your frequency for X should be V over 2L. This is our Fx. Okay, this is my Fx. How about the Fy? Fy is this is 1 over 4 wavelength. Okay, here like this. 1 over 4 is because here only, this part. You see this part. Okay, 1 over 4. From here to here. Equals to your 2L. So your wavelength is XL. Your Fy is actually V divided by XL. Okay, so boys and girls, here their velocity, their velocity, yes, their speed velocity is the same one because this is sound in the A. Okay, so for this kind of question, how we solve? They want to find a relationship between these two terms. For me, I will always using ratio. So I can using Fx divided by Fy, ratio. Okay, then Fx is V over 2L. Fy is divided, so I make it change to become times. I need to upside down, become XL divided by V. So at the end, V and V can cancel out because this is the speed of sound in the air are the same. Okay, then L and L cancel, then X over 2 is 4. Then here, Fx is equals to, my Fy move to another side, so it's 4Fy D. Okay, so for this case, is trying to test your understanding. Do you able to draw the pattern out? From the pattern, you can decide your wavelength. Then after that, you solve mathematic way. Okay, for this question, any question, dear? Is it okay? Every time in terms of what, okay, we just using ratio to find the question, to find the answer. So node to antinode is 1/4. Yes, dear, you look at here. Okay, for a while you have to agree. This is one complete wave. Do you agree? Year 10, okay? So that means that here to here is one complete wavelength. Agree? Okay, this one is half wavelength. Do you agree? Yes. So half and half again is 1/4. Okay? So therefore, this one, you see this pattern, actually is here. 1/4 wavelength. Okay? Any other question? Do you able to draw the pattern and then identify the wavelength? Manjo, I cannot do this. Why? Which one you cannot do? 1/4. Too small. Wait, let me have a look. Okay, boys and girls, wait, give me 1 minute. I read the Manjo answer. Okay. 1/4, 2L. Oh dear, 1/4 wavelength equals to 2L. So your wavelength actually is XL. Fy, above Fy, 1/4 wavelength is 2L. So your wavelength is XL. When you do substitution, you still substitute 2L. That is the mistake. Manjo? You get what I mean, dear Manjo? Here, your mistake is here. 1/4 wavelength equals to 2L. So wavelength should be 4 moved to another side is X. 4 times 2 is X. Manjo, okay or not, Manjo? The rest working steps are correct. Just this part you make mistake. Okay, dear, we goes to next page. Okay, here, this is a very common question asking in the your exam. Okay, so this one they adjust the tube. Okay, they adjust the tube. So remember, water is something like acting like close. Then open to the A. This is antinode. Must be antinode. Okay, touching to your surface of water is node. Okay, here they say that they adjust until they get the first frequency. Okay, first fundamental frequency producing a sound of a single frequency. Then after that, it will start to rise the tube. Okay, rising the tube to change the part. Okay, to change this, the length of the tube is adjust until fundamental stationary wave appear again. So one end close, one end open. The next pattern that we can get is this. Because I understand my open must be antinode, my close must be node. So this is my pattern, next pattern. If you forget already, come back to here. See? Close, open. This is my first pattern. After that, they adjust until they get another second stationary pattern. So they will get this pattern. Okay, this is the pattern. So I come back to here. So I get a pattern. So from here, can you see that? Okay. From here to here, antinode to antinode. How many wavelength? Half wavelength. So you're using your L2, the length, minus your L1. What you get? You get half wavelength. For this kind of question, they don't directly tell you what is the length. They want you find the length by yourself and you have to identify this is half wavelength. So again, one complete wavelength is like this. Okay, I make it vertically. It will be like this. Right? Okay, so at here, this one is anti. Okay, so this is anti-node. So from here to here actually is half wavelength. So L2 minus L1, actually what we get is half wavelength. Do you agree? Antinode to antinode at here is half wavelength. Okay, so we read it. L1 major, L2 major. So your L2 minus L1 is half wavelength. Wavelength is 2 times L2 minus L1. How I know wavelength? Just move, mathematics move. Okay, so at the end, we apply formula. So the behind is all the same. It's just how you find your wavelength. That's all. Okay, boys and girls, we go to page number 9. We try page number 9. Okay, first diagram, I draw it for you. Okay, I draw it for you. But exam don't have. Okay, you see, sometimes we do more partial question. Actually, their question will be repeated. Okay, here, we fill the water. The first two stationary waves occur when the column is the length is 0.14 and 0.42 meter because one end closed, one end open. Okay, so at here, I draw the diagram out. I will find out that the length different L2 and L1. This length different actually giving me what? Giving me half wavelength. Giving me half wavelength. Look at my diagram. Digest, do you able to accept my diagram? So at here, L2 minus L1 actually is half wavelength. Okay, so 0.42 minus 0.14 equals to half wavelength. Your wavelength should be 0.56 meter. That's all. If they're asking you to calculate the frequency, then V equals to F lambda. For this example, any question, dear? Any question? No question, can you give me a response? I assume that you get the idea. Yes, now if you get the idea, then we try question number 2. Idea are the same. Can you try question number 2? I go to the toilet. You try question number 2. Then come back. We will continue with next lesson. Okay, let me have a look. Question number 2. Power correct. Machine correct. Wesley correct. That means that you guys get the idea. Very good. So at here, it go down here. This is the first stationary wave pattern. You can see, you can hear. Banjo correct. Then another second one is here. Okay, the difference between these two, 83.5 minus the 0.1, make it become meter. Okay, 0.835 minus 0.171. Okay, this one is half what? Half wavelength. From here to here. Wait, from here to, from here to here. Let me have a look. Why I suddenly stuck? So this one is 0.835 minus 0.171. So we get 0.664. Am I my drawing wrongly? Jore. Jore, yes, Jore. Speed of sound. Let me think. What is my mistake for my diagram? It should be same as here. Am I right? Yeah. Wait, is it something wrong? Let me have a look. The first sound is heard when the water level is actually free. Oh my God. Like that here. Like this. Then after that, like this. Oh, my drawing just now is wrong. First sound is here when the water level is here. My drawing is wrong just now. Okay, so half wavelength. Wavelength will be 1.328 meter. The first note should be, yes, thank you, Joray. Yeah, thank you, Joray. So V equals to F lambda. So at here, 340 equals to frequency 1.328. Remember, convert to meter is because this is meter per second. Frequency is your B, 256 Hertz. Okay, the water level drawing, trying to confuse me. Okay, like boys and girls, if okay, we go to your next lesson. Diffraction is okay? Yes or no, dear? Yes or no? Yes, Manju okay. How about others? The rest of you? Machine okay? Okay, boys and girls, we go to diffraction. The rest is self-practice. Answer is provided at the bottom part. You just do it by yourself. Okay, if facing any problem, then you can message me lah. Okay, I will show you the complete one. Okay, diffraction. Okay. Actually, this one is year 10. We learned this before that, year 10. Okay, diffraction is the wave spread out. The wave spread out. Okay, when they pass through an edge or obstacle. So ripple tank is the common experiment, show the water wave. Ripple tank only show water wave. It cannot show the light wave and sound wave. No. Okay, so this is the ripple tank, and then the vibrator will move up, down, up, down, up, down, up, down. Okay, up, down, up, down. So there is a gap. So we observe what is the pattern. Okay, for the diffraction, if the effect is good, is it can be spread out and showing a circular path. Okay, circular wave front. So why we need to do this? Okay, in the what we say jetty, so we will build the retaining wall. Okay, retaining wall. The water wave coming, okay, so the water wave will spread out. If you're parking your boat at here, actually you can protect your boat. It's because after they spread out, can you see that their amplitude it decreases because they're coming and then they spread out to a wider region, so the amplitude become reduces. Amplitude can be related with the what energy, so energy of the wave also reduces. When the water wave hit on your boat will be not easily damaged. So this is the way why we need to build a retaining wall in this shape, and then the boat all these coming and then parking somewhere here. Okay, so at here, this is the two pattern about the diffraction effect. So at here, degree of spreading. Spreading out, we want to spread more. So first, longer wavelength. Second one, smaller gap size. Okay, how am I going to remember? Okay, we look at this one. Okay, if let's say your gap is very big, how am I teaching my student to remember the pattern is, you imagine this is the table between you and your friend. Okay, so your teacher coming, the teacher no need to do any changes. She can just pass through. Nothing happened. If your gap is big, it just goes through. So there is no spreading out of the wave. But imagine this is your table of your best friend. Trying to close as possible with your friend, so the gap is so small. The teacher coming, teacher want to pass through, cannot pass through. Then what the teacher do? Teacher have to change her own maybe move pass through the gap by using the side of body. Have to change a little bit. Cannot go through straight. Have to change and use the side and work and then go through here. You see your teacher already changing the the shape of the body. So at here, it will be changes of the shape of the wave. It will spread out. This is the method how I teach my students to remember. Big gap, then no effect. Just go through only. Small gap, how can I pass through? Change myself. Using the side go in, okay? Side of my body pass through. Okay, another one is, teacher, my gap I don't want to change. Okay, for example, this teacher, the gap is big. I don't want to change, but I want the effect spreading out. What should I do? Okay, your gap is big. Then if let's say no longer a female teacher, is a whatever foreigner, okay, their size is bigger. Okay, foreigner male teacher, their size is bigger. For them, for you, for Malaysian, we think that the gap is big enough. But for the foreigner male teacher, it might be small for them. So second method, if you didn't change the gap size, you can change the wavelength. Am I right? Change your wavelength, become longer wavelength. Wavelength something like your shape, body shape, okay? So if the foreigner male teacher come to the gap, although we think that the gap is enough for you to pass through, teacher, but no. Okay, because their size is big, wavelength is longer, so they will producing a circular wavefront. Okay, this is the method how I teach my students to remember about these two. Okay, so next, okay, here, in A level, we add one more. Diffraction, the effect is the most best effect is when the gap size is almost same as the wavelength is almost same with your gap size. At here and this condition, this is the best spreading out effect, which is the diffraction effect. Okay, the property that will change when diffraction is amplitude will change because they spread out, the energy dissipated. When they spread out to a larger area, the energy is spreading out. So amplitude is decreases. Okay. Any type of wave can be diffracted. Sound like water. Okay. Radio wave. Okay, moving between around the building. Okay, water wave passing through a gap in the harbor. Okay, this is the light intensity pattern when they're passing through a narrow slit. Okay, so this one is laser pen. Okay, laser pen come out with the light. Monochromatic light, which is the light with the single frequency or single wavelength. Okay, so year 10 we learn monochromatic light is the light with the single frequency or wavelength. So at here, this is the pattern that we can saw on the screen. Okay, we will saw the pattern like this. Okay, bright dark fringes when they're spreading out. So this is the pattern. Okay, next we go to your next page. Okay, we go to your next page. What happened when we change your wavelength? Okay, change your wavelength. So at here, they like to asking you, red light and blue light. So they didn't tell you what happened to the red light and blue light wavelength. We understand light, their wavelength will be changed. So from here, you have to recall back what I teach you about your EM wave. Okay, EM wave. Ramly make Indian vegetable untuk ex-girlfriend. Am I right? Ex-girlfriend break up. Okay, make Indian vegetable for the ex-girlfriend untuk ex-girlfriend. Girlfriend, when they quarrel, frequency is high. Their wavelength is short. Okay, girlfriend slim so wavelength is short. Wavelength is short. Visible light at here, we are starting from red until violet. So blue is in between here. Ask yourself, red is longer wavelength or shorter wavelength compared to blue? Since here girlfriend is wavelength shorter, then radio must be longer wavelength. Your red color is nearer to your radio, close to your radio, far from your girlfriend. So compared to your blue color, your red color is actually longer wavelength. Okay? Longer wavelength, the fat teacher want to pass through the gap. It will producing a more effect of the diffraction. That's why at here, for this diagram, you see this is the pattern. Okay? Then blue light is shorter wavelength. What else? The angle of diffraction, increase the angle of diffraction when your wavelength increase. So the wave will diffract more. Okay, diffract more. So angle of diffraction increase. So it will spread out more lah. Okay, spread out more. So the width of the bright maxima also increase. So at here, bright to bright also increases compared to here. Okay, for the case number 1 about the change of wavelength, is that clear for you, dear? Is it clear for you, dear? Okay, Fawa, okay. Machine, okay. So you have to remember about this, Okay, dear, next. Change in the slit. So you want the gap small or big so that you can diffract more. Think back, you and your best friend table in between. The gap is small, then your teacher had to pass. Okay, so how? Your teacher have to change body, okay, change to side, then move. So at here, if the slit become narrower, the angle of diffraction will be greater, it will spread more. Okay, it will spread more. Okay, so this is the pattern. This is wide slit, this one is narrow slit. So the pattern will be much more what we say, more diffraction. Okay, more diffraction. So they say intensity graph can show you that intensity center part is actually is the highest intensity. Then they will decreases. See, decreases. Okay, what else they will tell us? The width of the maxima is increases. So here to here increases higher. Oh no, this is the intensity. Okay, the width. Okay, increases. The spacing between the fringes is wider. Okay, so these two is the factor affecting the the diffraction effect. Okay, until here, is that clear? Oh, is it okay? If okay, we go to page 4. No response. Okay, can Fawal, okay, only Fawal. Okay, we try with past year question. Lydia, can you try 2020? Which statement must be true? Must be true to occur when a wave passes through a gap. Manjo, very good. Yes, Manjo is the first person answer me. Who else? Fawal. Yes, Fawal. Okay, boys and girls, answer B. It must be a progressive. Why? Why? If you are stationary, cannot. Washini, correct? If you are stationary, you didn't move what? Your wave profile doesn't move what? Then how you pass through the gap? Okay, how you pass through the gap? So here, B is correct answer. Okay, must be able to travel in vacuum? No. Light can be in vacuum what? It must be larger amplitude. No, we no such requirement. Okay, no such requirement. Must be long wavelength. Cannot say mass. Okay, cannot say mass. If you are having a longer wavelength, the effect will be not mass. The wavelength will be, the diffraction effect will be more obvious. That's all. Cannot say mass. If you are shorter wavelength, it still can have some diffraction. What? The effect is not obvious only. Okay, question number 2. Okay, what is your answer, dear? Vashini, correct. Prasan, correct. Greatest diffraction is when your wavelength equals to your gap size. Am I right? Wesley, correct. Answer should be donkey. Okay, what wavelength? It should be 8 meter. Okay, next, number 3. Which diagram is correct? This one year 10 also can answer. Vashini correct. Okay, dear, only Vashini get correct. How come? It's year 10 question also can answer what, dear? First, diffraction of water wave. We didn't change the depth. Depth is constant. So your speed and your wavelength should not be changed. This one, why wavelength changes? No. Wavelength should be the same, what, dear? So adhere to fulfill this, answer should be B. Okay, answer should be B. Wavelength size are the same. Any question? Okay, we go to question number 4. Can you try how to increase the amount of diffraction? Idea number 4. Which change can increase the amount of diffraction? Distance between the bar and the gap. No, Manjo. Read properly. Vashini correct. Wesley correct. Prasan correct. Bawal no. Bawal no. Amount of diffraction to be obvious, obvious. So just now I told you two. Either is your gap size becomes small. Okay, it becomes small. Then second one is your wavelength become longer. If this 20 cm, the gap size cannot change, then you change your vibrating bar, change the frequency to producing a longer wavelength. The wavelength must be longer than this, okay, or same size as the gap size, only got diffraction effect. So at here, our answer should be B, boy. Yes, Fawa correct. Okay, so Manjo, do you know what is your problem? You are trying to changes from this to hit this distance, but this distance doesn't affecting anything. Manjo, okay? Your A is here. Make it nearer. Doesn't anything. Okay, last number 5. Like tell me, number 5, try. I send out right now. I try to send out the worksheet for the next one. Okay, you download it. If you are using iPad to study, then you download it and use it. But if you didn't use iPad, you normally is printing out. Then where then you take out a piece of paper, you write. Okay, this is my fault. I'm so sorry about my fault. I did trying to send out, but my school Wi-Fi is the public Wi-Fi is really lousier, you know. Sorry to say. Okay. It didn't success to send out, but I didn't realize about that. Okay. So for those normally we print out the worksheet to do. Okay, I'm so sorry for that. But what I can do is for the next lesson, I promise I give you the full model answer because of my fault. Okay, so today you just take out a piece of paper, but if you're using iPad to do study, so you can download the file, then we continue next lesson. Okay, Vashini correct. Manjo correct. Okay, like boys and girls, for this number 5, answer is B. When you're decreasing your period, you are increasing your frequency because frequency is 1 over period. Frequency increase, your wavelength will become shorter. So this one will decrease the amount of diffraction. V equals to F lambda. the speed is constant because I didn't change any I didn't changes electromagnetic wave. For example, electromagnetic wave. I can think about light wave. Light in the air. All the time is 3 times 10 power of 8 meter per second. I didn't change what? It's constant. So if like this, my frequency increase, my wavelength will decrease. Is that clear? Maybe we can in the notes at here, dear. Maybe in the notes at here, wavelength become longer, so greater spreading, or we say frequency become lower. How you make frequency become lower? Maybe your period can be higher. Something like that. You take some notes, they are affecting each others. Okay, if you're done for this part, can you go to question number 6? 6A. It should be easy, what, dear? Nothing to calculate, what? What is your answer for 6? 6, question 6. Vashini, correct. How about others? Gap slowly widen. Okay, wider gap, bigger gap. What's going on with your angle? It will spread more or spread less? Manjo, correct. Prasan, correct. Okay, because here gap size become wider, so your diffraction effect will be reduced. So this angle can be reduced. It will reduce. Wavelength are the same, dear. Wavelength are the same. Why wavelength are the same? Okay, here water wave. Water wave, how you change the wavelength? The depth of water wave. If you are in deep region, water wave, water actually is moving fast. If you are in shallow region, actually is moving slow. Okay, V equals to F lambda. If frequency constant, then speed does not change. Your wavelength will not be changed also. So in water wave, wavelength, as long as you didn't change the depth, your wavelength should be the constant. It won't change. So if you measure this wavelength 2. Here is wavelength 1. Wavelength 1 should be equal to wavelength 2. Year 10 we already learned it won't changes your wavelength. Okay, here deep region is moving fast, shallow region is moving slow. Do you know how to memorize? I teach my student in this way. Pronounce shallow 10 times in a very fast speed. Shallow, 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 slow, dear. Slow, dear. Okay? Changing speed and changing the wavelength only when the depth of the water depth is changes. Okay, for question number 6, is it okay? Can I go to question number 7? Yes, Vashini, okay. How about others? Fawa, okay, Manjo, okay. Jore, okay or not, Jore? Okay, dear, here. Can you try for the next question? Okay, Jore, okay. Question number 7, dear. Vashini, correct. How about others? Manjo, correct. Fawal, correct. Fawal, confidence. Okay, Wesley, correct. Be confident, Fawal. Okay, answer is B, okay, here, dear. Answer is B. Can detect radio wave. Hey, blocking, dear. Blocking, how come I still can detect? It's because it deflected what? Okay, it deflected. Come here, deflected. Come here, deflected. Come here, deflected. Okay, so I can receive the signal, although there is some obstacle. Okay, so here diffraction can be happen. But this one not for microwave, not obvious. Diffraction not obvious. So what is the difference between radio and micro? Okay, one can diffract, another one cannot. But why? Just now I told you the EM wave Ramli makan Indian vegetable untuk ex-girlfriend. Wavelength longer for the radio. Then for the microwave, wavelength is shorter. This wavelength shorter, so the effect of the diffraction not that obvious. So your answer will be B. Okay, one more we learn in year 10 or we learn in form 5 about wave. Okay, we say that your friend standing outside the door, you cannot see, but you can hear her sound, talking something bad about you. You can hear. Why? You cannot see him or her, but you can hear the sound. It's because sound can be easily diffracted. You cannot see, it's because the light wave, the wavelength for light is shorter, so it cannot, it hardly to diffracted into our eyes. But sound, yes, sound wavelength is longer, it can be diffracted easily, so we can hear about that. Okay, boys and girls, is that clear for this lesson? The next lesson is the one that I just sent out. If you are using iPad, then you download it. If you don't have the iPad, okay, you are printing out. I'm so sorry about that. Really, it's my mistake. Okay, so you take out a piece of paper. You whatever. Then you can try and write down, jot down. Okay, I promise for this lesson, the whole set model answer I provided to you guys. Okay, even though you don't have the worksheet, maybe you didn't write down something. It's okay. I provide all the working step in my model answer I will provide. Okay, here boys and girls, is it okay? We go to the next interference. Is it okay, dear? Well, yes. Ashley, okay. Okay, I assume okay. Okay, interference is occurs when the wave overlap. Okay, wave overlap, and their resultant displacement is the sum of the displacement of each wave. Okay, they overlap. So for example, at here, this one plus this one, crest plus crest, we get a bigger crest. This is called interference. They add it up, they overlap, and then we add it up their displacement. Okay, so this is based on superposition. So when we starting learn about this chapter 8, we already talked about this part. Okay, now we are continue on the knowledge. Interference, we got two. One is constructive. Okay, you get a bigger amplitude, bigger displacement. So this is called constructive interference. If you cancel out each other, the crest cancel out with a trough, then it will be get zero. This is called destructive interference. Okay, for the interference to be observed, we want to observe the interference, we need to have two coherent source wave is required. This one is important. Okay, what it means by coherence? Coherence. I make a star is because there's so many parts here. They ask you what is the meaning by coherence. So you have to memorize the meanings of coherence. Constant phase difference between the wave. Okay, so at here there must be same frequency, same constant phase difference. Okay, this is considered as coherent. This is not coherent. Okay, they change in phase. Okay, so at here, for example, this and this, they will cancel out. So they will form destructive interference. Okay, crest meet trough. Then trough meet crest. Crest meet trough. crest, trough, mid, crest, something like this from time to time. They are constant phase difference and then same frequency. Okay, we goes here with electromagnetic wave. Two wave also have to polarize in the same plane to be coherent. Okay, so we need to EM wave, we need to polarize it. Okay, we need to polarize it so that to make it coherent. Okay, this is the knowledge. If not mistaken, some of the MCQ they are testing on this knowledge. Okay, we go to your next page. Two source interference. Interference is two waves that overlap one. So you must have the source, two source. Okay, the two source must be coherent and monochromatic. Okay, if light is monochromatic, single wavelength or single frequency. Okay, so laser we use the laser pointer. We found out that it's come out with red color or green color or whatever color, only one single color. But of course, the definition for monochromatic, we cannot say single color lah. In year 10, we know, okay, the best answer is single frequency or single wavelength. Although we understand it's single color lah, okay, but that is not the definition. Okay, coherent monochromatic light, a laser is the example. Okay, here for water wave, so we will have two dipper at here, up, down, up, down, up, down. So we are producing at the end, at the bottom part at here, we observe, we will get this kind of pattern. Okay, two wave, the interference, okay? This is one of the wave, then this is another wave. From these two dipper, okay, vibrator. So at here, blue color is come from S2. Blue color is come from S2. Then the red color is come from S1. These two waves, they overlap. Okay, they overlap. So at here, if solid line, meaning that this is crest. Crest to crest in between, of course, we got trough lah. Okay, one complete wave, crest to crest. For example, here like this, like this. Okay, crest to crest. Okay, in between them got one trough. Crest to crest, we got the trough, right? So at here, they're using dotted line to show your trough. They can just drawing solid line, then assume you know that in between got trough also can. Okay, doesn't necessarily they have to draw everything for you. Okay, so we look at few point at here. Okay, when the trough meet with another source of trough, you see this one pink color trough and the blue color trough. When they are overlap, trough and trough, we get a bigger trough. So this one is constructive interference. This point is constructive. Then next, solid, solid, that means that is crest. Crest meet another solid like crest. Crest meet crest. Again, we get a constructive also. Okay? Trough meet trough. Trough plus trough. We get a bigger trough. Crest plus crest. We get a bigger crest. Okay? This one again is trough plus trough. Crest plus crest. So along this line, that point, we draw a line. This line called antinodal line. For those who graduate from Malaysia syllabus SPM, this is not a new thing for you lah. But if you are graduate from IGCSE, this is something new for you. Okay, you might be take times to understand it. Okay, so at here, here this diagram, they shape point P. Point P is two solid line from two source. So it's crest plus crest, it get bigger crest. So constructive. Point Q, trough plus trough. So we get a bigger trough, also constructive. Point R is here. You see point R, one solid line crest. Overlap with a dotted line, trough. Crest plus trough, I get a destructive. So these two is called constructive interference. This one is called destructive interference. Okay, until here, any question? Until here? Until here, any question? No question? Give me response, then we go to next page. No question. Good job. Forward. Okay. Like there go. For the sound wave, okay, we will also able to interference to get the pattern of what? Loud sound, quiet sound, loud sound. If loud sound is because constructive interference. Quiet sound is because destructive. Okay, is it okay? Okay, next light. We will get bright fringes, dark fringes, bright fringes, dark fringes. If bright fringes is because constructive interference, dark is because destructive interference. Is it okay? Okay, here microwave, same thing. Okay, the detector is moving. Here, move, and detect. Maximum amplitude is because constructive interference. Then you get minimum or zero amplitude is because destructive. Okay, so we comes to the past year question. For those you don't have, also never mind. You read from my screen here. Okay, read it and then you type your answer in the chat box. Tell me. What is your answer for question number 1? This is 2024, last year past year question. Jory, correct. It's just Jory. Wesley, correct. Farwell, no. Washini, correct. Prasan, correct. Manjo, correct. Okay, what is the mass for coherent wave? Here, mass for the coherent wave. There must be same frequency, constant phase difference. Okay, constant phase difference. So your answer mass is this one, C. Okay, question number 2. Why can an observable interference pattern never be obtained between two monochromatic light from a different lamps? Never be obtained. Why? Why? Two monochromatic beam of light from different lamps never able to get the observable interference pattern. Why? But wow, just now first question, do you know what is your mistake? They no need to travel in opposite direction. Okay? Two source. They are the same direction. What? Interference. Okay, number 2. What is you guys' answer? Tell me. Yes, Manjo, correct. Never be able to obtain. There must be some problems with that. They say that why? They never be coherent, but we must coherent. Must. For interference pattern to be observed, they must. So why they never can be observed is because they never be coherent. This one cannot. Okay, that's why cannot observe. Okay, number 3. Like boys and girls. Hey, why double slit? Wait. Yeah. Okay. Why before the double slit? Two wave producing at here. Okay, two wave producing at here. Why before that I need a single light? Single slit. What do you think? Answer for question number 2 is B, Wesley. B. Why it never able to observe the interference is because it never be coherent, cannot, must coherent. Wesley, okay? Yeah. Manjo. Manjo, no. Almost there. Vashini, correct. Okay, dear, here. To let the interference to be observed, okay, we need to have a coherent light. Coherent light. So answer should be C, Wesley, correct. Fawal, correct. Prasan, no. But you almost there lah, okay? So at here, answer should be C. We want to provide coherent light. Okay, so at here, this one, coherent light. So actually, I was trying to make notes at here, okay? Before I producing these two, I want to make sure these two wave, whatever frequency or whatever their phase different are the same. So before that, I make one diffract first. Then from here, they diffract out. Diffraction happen at here. Then before interference happen. Okay, boys and girls, we go to question number 4. Should be 4, but my numbering got problem. It's okay. Number 3 at here. Okay. Read the question and then you tell me what is your answer. Two wave, constant amplitude interference, producing the interference pattern. The pattern has a minima. Ask yourself, minima is constructive or destructive? Oh, where the displacement is 0 at all the time. Oh, okay. They already told you what displacement is 0 when minima. So construct or destruct. So how you producing the construct or destruct interference pattern? Fawal, no, but you almost there. Wesley, no, but you almost there. Minima, that means that destructive interference. Destructive, displacement is 0. Just now, you choose Wesley and Fawal choose the answer. It's wrong is because not necessary to have same amplitude. If you are not necessary, this one is 2A plus 1A. Will you able to get a destructive interference? No. Destructive becomes 0. Then must be same amplitude. A plus A. Meet up, then become 0. Fawal and who? Wesley, do you get my idea? Do you get my idea? Fawal, okay already. Jore, no. Must coherent. Jore, so today, interference pattern to be observed must coherent. Okay, must coherent. Okay, Fawal get the idea already. Prasan, so A. Yes, dear. Prasan answer is A. Must same amplitude and must coherent. Okay? If you are different amplitude, this is what I say. 2A meet with a trough with 1A. At the end, will you able to get a 0? No, you won't get a 0. What? You're still getting a small a here. Here they say minima and displacement is 0. So must be able to cancel out. If you want to cancel out, they must same amplitude. And then some more, this is called interference. So must have coherent. That's why in my notes at here, first page at here, you see? Very important, must coherent. For interference to be observed, coherent source is needed. Okay, definition. For coherent, constant phase difference. Okay, dear, here next. Okay, here, number 4. This one. Where is the loudest sound can be heard? I got 2 loudspeakers behind the stage. In order to test the speaker, they are meant to emit the sound of the same wavelength and the same amplitude. The curve represents the wavefront. Okay, wavefront. So at here only solid line. That means that they didn't show you the the dotted line lah. Prasan, try one more time. Loudest sound is actually constructive or destructive. Yeah, Manjo, too easy for you, right? From 5, you learn this. Vashini, correct. Okay, dear, must be very clear. Loud sound is construct or destruct. Ask yourself, constructive or destructive? Fawa, correct. So write it down. This one is constructive interference. This is constructive. If constructive must be, Prasan, correct. Constructive must be crest to crest or trough mid trough. Okay? Jore, correct. Okay, so boys and girls, you see A at here, actually in between. Here we got a dotted line. Crest mid with trough. No, this is not my answer. So this one is not in between. So this one, the sound, it might be construct, but not a maximum displacement. Okay, for B, one crest meet in one craft. So this one is destructive. No. Answer is donkey. You see, crest meet with trough. Crest from this, meet with trough from this. The two wave from two sources, the interference overlapped and then crest meet with crest, so it will form a louder sound. Answer should be donkey. Is that clear? Yes or no, dear? Okay, so we try with question number 5. Any of you cannot? Let me know. Okay, if done, go down. Yes, teacher. Okay, here. 2019. At which point? Okay, at which point does the destructive interference can be happen? Hmm. For a while almost there. Destructive. Destructive is what and what meet each others. Let me have a look. Is it correct? Oh, no, 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 no. For a while, no. Think again. Manjo? No. Manjo, no. Destructive. Manjo, no. Bawa also no. Vashini, correct. Manjo? 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 Manjo, no. Where is your destructive interference? Wesley also no. A is the gap, what, dear? A is the gap. A didn't happen in interference, what? Interference is the two waves they overlap. Two waves that overlap. So boys and girls, you see at here is just come out. Haven't overlap yet. Overlap is somewhere here overlap. Two wave overlap. So your answer impossible is A. Wesley, yes. The second answer is correct. Jore, no. Jore, ask yourself. Destructive is what and what meet each others. For a while, you already get the answer. Yes. Okay, boys and girls, answer is C. Okay, Fawa asks why teacher answer is C. Destructive, dear. Destructive, or we say minimum, destructive is when a crest meet with a trough, we get a 0. This is called destructive. Am I right? Come back to here if you forget already. See? Destructive interference is a crest meet with a trough. I get 0. Right? Okay, so I come back to just now here. Ask yourself, okay, B at here. You see B at here is crest meet with crest. So B should be constructive. Crest meet with crest. Okay, C leh? C at here is a is a trough meet with a crest. This one, see? Okay, this is one of the wave here. So this one is the trough. Solid line, dotted line. So it's one crest meet with one trough. This is crest meet with trough. So you get destructive. Answer should be C. How about D? D is here is another wave with a crest, with a trough. So two solid line meet each other. So trough meet trough, we get a bigger trough. So D is the constructive. Constructive. B is crest meet crest. Crest meet crest. We get a bigger crest. This is constructive. Answer should be C. Like, Manjo, do you know your problem about this question? How about others? Fawang, did I answer your question? Did you able to get my point? Okay, yes. How about Manjo? Yes, Manjo. Yeah, your third answer is correct. Now I just understand it right now. Okay, how about others? Okay, then we go to your next page. Can I go to your next page, dear? Or you still trying to copying something? Can I? Fawa, okay. Only Fawa, okay? How about others? Jore, can I proceed? Okay. Machine, okay. Like dear, next. Okay, dear, here. On the line 5.1 represent the wavefront. All the points on the wavefront are in phase. Okay, they're asking you to mark a point with a cross positions of the interference maximum. Maximum can be crest, mid crest, or trough, mid trough. Okay, so at here it can be maximum crest, mid crest, or trough, mid trough. Okay, then you label Y. Easy lah. Here. A and B are two sources producing the coherent wave. The waves are emitted in phase. Phase difference is constant. Okay, wavelength is here. Okay, so at here you can choose any point as long as it's crest mid crest. Oh, sorry, it's close. We want us to close it, this point. And then label this as Y. Okay, for a minimum, that means that destructive. If destructive, must be a crest meet with a trough. Okay, crest meet with a trough. So at here, all these are crests. They all are in phase crest. Okay, so how you can draw at any point as long as one crest meet with another trough. So I can just simply draw at here, close it, label this is my Z. That's all. Is it okay? Yes or no, dear? We are going to, although we got 7 minutes, but we are going to enter a very challenging subtopic about path difference. Okay, until here, is that clear? Can we continue page number 7? Yes. Okay, here, dear. This is not easy. This topic is not easy. Okay. Previously, what we learned is called phase difference. Okay, between the two phase, their distance in between them in how many degree or radians. Okay, this is called path difference. Path is the distance. Okay, extra distance that another one wave travel compared to another one. Okay, path difference between two coherent wave can helping us to understand at the end we will get constructive or destructive interference when they meet up. Okay, for example, here this is their path difference. Okay, what is the distance, extra distance travel? Okay, so at here, this is their path difference. At the end, okay, they are crest and crest, crest and crest until the end. Let's say at here, crest and crest meet. So I know that this pattern we will get a constructive interference. We will get a constructive interference. Okay, for destructive is my path difference is half wavelength. This is half wavelength. This is one complete wavelength. So now their different distance is half wavelength. If half wavelength, can you see that when they are meet up at here, actually they are out of phase. It's 180-degree difference. So this is crest, this is trough, meet with a crest. So at the end, what they get? They get a destructive interference. Okay, we look at here. So we got two waves. Ta, 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 ta. This is another wave, okay? So it's something like this. The wave here, bottom part at here, wave. Maybe we can look at the example at here. Okay, we look at the example. The blue color at here, this is one complete wave. Agree? I already labeled for you. This is one complete wave. How many complete wave when I'm from S2 to P2? How many complete wave? We count. 1, 2, 3, 4, 5, 6. From S2 to P2, I got 6 complete wavelength. Is that clear until here? Okay. Now, we look at the purple color S1. This just now is S2 travel to P2. Now I want to know these two. When they meet up each others at P2, we will get an interference is constructive or destructive. So how? Okay, we look at this purple color. 1, 2, 3, 4, 5, 6, 7. I got 7 wavelength. So my 7 wavelength, what is their path different? I travel S1, I travel extra 1 wavelength. 7 wavelength minus 6 wavelength, I got extra 1 wavelength. Extra 1 wavelength, you look at this. Extra 1 wavelength, at the end, you still crest meet with crest or trough meet with the trough. So for the P2 at here, the wave from the S2 and S1 at point P2, they will form a constructive interference. Why one complete wavelength will be constructive? Here. One complete wavelength different. At the end, their phase different at here, crest will meet with crest or trough will meet with trough. So all the time at this P2, they will get a constructive interference. Until here, did you able to understand my idea, dear? Did you able to get the idea? Manjo, yes. Vashini, okay. Fawa, okay. Prasan, not really. Okay, Prasan, one more time. Prasan here. It's okay, no need to say sorry. Prasan, you look at here. Starting, if let's say 2 loudspeaker is placing at here, so they don't have any path different. They are traveling from the same distance and then go up. If let's say I move one of the speaker backwards to here, okay? So they will form a path different. For this case is their path different is one complete wave. So at the end, you are founding up these two sources, their wave pattern until the point that we intercept them, crest meet with crest, they form a constructive interference. So if their path difference is one complete wavelength or n complete wavelength, 1, 2, 3 complete wavelength, doesn't matter. At the end, when they intercept, they will get constructive interference. So for Prasan, this part, can you understand this part? Can okay, so one complete wavelength, it will form constructive is because they will get the same phase meet each others. So you look at this S2. S2 is the source that it will producing the blue color wave. Okay, if we count it properly, this one count it properly, at the end from S2 until P2, I can able to count 6 complete wavelength. Until here, Prasan, okay? Can. Okay, I want to know P2 is actually from S2 wave and S1 wave meet each other, which means that this blue color and purple color, they meet up each others. So I want to know when they meet up, actually they are producing constructive or destructive. So you count the purple color at here. 1, 2, 3, 4, 5, 6, 7. So 7 minus 6, this is their path difference. Path. So that means that S1 wave travel one path, one complete wavelength compared to S2 wave. So at the end, can you see here crest meet with crest. So this part actually crest meet with crest. So at the end, we get a constructive. But here, we look at the P1 here, okay, P1. If you count this one, blue color, 1, 2, 3, 4, 5, 6, 6.5, dear. From S2 to P1, it travels 6.5 wavelength. How about the purple color from S1? We count 1, 2, 3, 4, 5, 6. S1 that travels 6 wavelength, S2 that travels 6.5 wavelength. That means that their path difference actually is half wavelength. Their path difference is half wavelength different. So when half wavelength different, you see, at here, this one is crest. This one coming is trough. Crest plus trough, at the end, they form a destructive. So boys and girls, did you get the idea? Path difference can helping us to decide whether constructive interference is happening or destructive interference is happening. So boys and girls, for this one, can you able to get the idea, roughly basic idea? Is it okay? Okay, so before we end, okay, here is summary. Okay, summary, if your difference is if your difference path difference is one complete wave, for example, this one is here, this is one complete wave okay. So can you see that at the end when they meet up is crest plus trough plus trough. So if you are n wavelength, no matter is one wavelength different, two wavelength different, three wavelength different, they will form constructive interference. But if, for example, this one is 1 plus half, 1.5 lah. Okay, then this one is 1, 2, 3. 3 wavelength minus 1.5. Your path difference is 1.5 wavelength. So it's m plus 1 over 2. Actually, it's this idea. Then 1, let's say 1 plus 1 over 2. That means that in front we got one more lah. But doesn't matter. Here, they are different is half. Half, when half, you see, at the end when they meet up, this is crest. Here is trough. So they will form destructive interference. So this is the knowledge that I want to bring to you. Until here, is that clear? Is that clear? Okay or not, dear? Okay, so next week we continue with this. Okay, so you print it out the worksheet after that. Okay, that's all for our lesson today. Thank you, class. Bye bye.